Okay, we're going to look at key points in parent function. So these two are functions that you are familiar with, whether you recognize them or not by this point. And these might be some new ones for you guys. So this one here, remember f at x can really just be replaced with the letter y, right? We just write f at x because it's called function notation. So the function with the variable x in it is also known as y at x. Technically, it's to the power of 1, though we never write it. Do you know what type of function this is, or what kind of relationship? I'll help you. This is a linear relationship, which means, what does its graph look like? Remember? Linear stands for
just a line.
Just a straight line. That's it. That's what that is. Okay. Now, I called it g at x, and the reason I called it g at x because technically, if I were to call this f at x again, well then I have contradicting statements. I have two functions by the letter f. So we use different letters in function notation to represent what would be considered a different relationship or a different function. Okay. So we have f at x to represent the linear function, g at x. And this is no longer to the power of 1, linear is power of 1, x to the power of 2. Do you know what function this would be? At all?
Would it be like a parabola?
Yeah, it's definitely quadratic. And do you remember what quadratic looks like in terms of a graph in general?
Yeah, the parabola.
Yeah, it's called a parabola. It's got like a U shape to it, whether it's up or down. Okay, good. So we recognize these. Okay, now h at x. We use the letter h just because it's a different type of function. This is considered a root function, and it's technically the square root. Okay, so the square root of a function. Now this one looks a little different. They usually call it the root function, but technically it should be called a square root, as in it's the root of 2. This is a little different looking. This is kind of like a sideways parabola. Okay, in order for it to be a function, and normally a sideways parabola would look like this, right? We have the u. But in order for it to be a function, it has to pass something called a vertical line test, and it wouldn't pass the vertical line test if it was drawn with the entire u. The sideways u for a function has to pass something called a vertical line test, so we don't draw the other half of the u, we just draw the top half for now, okay? J at x, there's a whole other function called an absolute. Do you remember doing absolute values at all? So. Yeah, in elementary school they would have done absolute values. So absolute. An absolute function, it looks like a V. So it looks like two linear lines that connect almost like they have a vertex similar to a quadratic, except it's not U-shaped, it's a V-shaped. They're very straight lines, okay? And then finally, and this one is, they're probably going to be the hardest for us to graph. Let's use a different color here. Okay, whoops, no, that's good. Okay, this is a reciprocal function. And a reciprocal function has this. It has two things that are called asymptotes, where it gets really close, the parent function at least, gets really close to the x-axis and the y-axis, and then down here again does something very similar. Have I drawn it downwards? Yeah. So, a very different idea of this reciprocal function. It's almost like there's two separate lines to it. So this one's kind of hard to draw. So we're going to look at just some key points of our normal functions, okay? And normally for key points, you'd make a table, and the tables are pretty simple to work through. And we'll kind of create a table quickly for each one, but we're going to show them on a graph. So for a table, you would have your x values and a y values. So normally your x values, you know, if it's linear, a lot of times you start at -3, -2, -1, 0, 1, 2, right? That's a simple idea. So let's go over here. We called the first one f at x, okay? And like we said, that's our linear line here. And what this can do for us is it can turn this into a table. That's what's really neat about this program. So here are some major points on it, right? We have -2, -1, -1, -1, 0, 0, 1, 1, 2, 2. This is considered the parent function. In other words, this is the original. If we ever do transformations, we'd be talking about from this function here. Okay? I'm going to quickly just turn this one off. Okay. Let's build our next function. The next one we called g at x, and it was equal to x to the power of 2. Whoops, not capital X, just x to the power of 2. And like we said, it's our parabola, right? Again, we're going to convert this to a table. And for a parabola, these are some of the key points. You have 0, 0, negative 1, 1, 1, 1, 2, 4, 2, 4. Sometimes they would even do 3, 9, 3, 9, but that's fine. These are 5 key points in a parabola, okay? And these are all really important because this is the parent function of parabola. These are all the key points come from, okay? Let's turn that off. Let's look at, like we said, what was the letter we used? Oh, geez. H. Okay. H at x is equal to the square root of x. Okay, so like I said, remember, it didn't draw the bottom half of u. It only drew the top half. And same idea, we're going to look at some key points of this function, okay? Now, if you notice, it started at -2 and it said it was undefined. -1 is undefined. Then it had 0 and 1. It didn't really use great points, so I'm going to add a few into this here. But let's talk about what -2. Why is -2 undefined? Really tough idea. So let's try to find the square root of -2. Can we do it on the calculators? We can't find the square root of -2 because you can't have 2 of the same numbers multiplied and make a negative, right? It says non-existent, it doesn't exist. So it's essentially an error on many of the calculators. It's not possible. So this function doesn't exist to the left of it. So if we're talking about like the domain of it, it would only be greater than 0. It only exists to the right for this parent function. I'm going to change some of these values. 0 is a really nice one, okay. 2 is okay. What I'll start with is the next, and again 2. The square root of 2 would be 1.4. It's not a number we memorize. The next one that's really good is usually 4. And the reason we use 4 is because we can find the square root of 4. It's pretty simple, right? Square root of 4 is 2. What's the next number we can easily find the square root of after 4? 9. There we go. And it shows us 9, 3. Now let's continue that pattern. What's another one? 16. Even though it doesn't show up on our graph, technically. There it is. 16, 4. Okay? So those are what some of the key points are to that parent function, to that root function. Okay? So you'd kind of have to keep those in mind when building it. Okay? Let's turn that guy off. The next function we said was absolute. I think we called it j. Okay. J at x is equal to the absolute value of x. Here we go. So remember I told you this one has a V shape to it. It's got a vertex similar to a parabola. Let's change it into a table and see what it does. Convert to a table. So some of the key points. 1 is 1. 2 is 2. -1 is 1. -2 is 2. And this -1, 1 is similar to, if you remember our parabola. Let's turn the parabola on again. Here it was. Okay. These 2 points are the exact same. The only difference is whatever negative value it is, we turn it directly into the positive value, right? So 4, 4 is also another point along here, where that's not the case with the parabola because we're squaring things in a parabola. Okay, I'm going to give you, I'll help you out in a sec. Does this idea make sense? Yeah? Okay, and then the last one. The last function, the reciprocal function, is the hardest one to look at. We called it p. P at x is equal to 1 over x. Okay? Okay, so very, very different looking function. Okay, and we're going to just look again at some of the key points of this parent function. This is the original. So, -2 and 0.5. Well, if I plug -2 in there, I get 1 over -2, which is a half. So I get -1/2. That makes sense for a y value. Okay. Another y value is -1 and 1. Okay. And then 0 is undefined. So remember I told you this function never touches the y-intercept. Okay, or sorry, the y-axis. And then 1, 1 we get, and 2.5. Okay, these are okay, but they're not the best. So I'm going to add a few extra in here. If I can go up. I can't quite. I'm going to turn this guy into -3. -3, -2, -1. Okay, these are all points that are kind of helpful. And I'm going to show you some of the other ones that are actually really helpful. We're also going to look at, is it easier if I write a fraction or a decimal for you?
Fraction.
Fraction? Okay. 1/2. Oops, that wasn't 1/2. 1 over 2. Okay. And 1 over 2 gives you the value of 2. Oh, sorry, I want it -1 over 2. -1 over 2. Okay. It's essentially flipping it. So you'll notice this point here, I'll turn this guy off and this guy off. They have kind of like inverted values. Okay. -1/3. Okay. That gives us this, and these guys have inverted values, okay? And they're not writing it as fractions, okay? But these are some of the key points in a reciprocal function. It gets really, really close to the x-axis and really, really close to the y-axis, but never touches. We said 0 is undefined, we know that. And then we can do these same things just in the positive range. We'll use a positive third, and one of its key points is 3. Positive a half, its key point is 2. The value of 1 is 1, we know that. Okay. And then we get the value of 2, which is a half. And then finally the value of 3, which is a third. Again, so similar to the -1. So I've gone through a lot more key points in this reciprocal function. And this one's a much tougher one to work with. We're not quite used to that. Okay. So these are all of them. We'll kind of zoom out. Oh, shoot. Okay. These are the key points in some of the parent functions you need to know.